Hello everyone, I am Abhishek Sharma, Faculty of Mathematics at SRN International School situated at Jagatpura, Jaipur. I welcome you all on the official YouTube channel of SRN International School. In today's video, we are going to have a subject of Mathematics Grade 11th NCERT, Chapter number 12, Three-Dimensional Geometry. So let's begin with the topic. Now we are going to have the introduction to three-dimensional geometry. The main terminologies which we are going to have when we are dealing with the chapter of three-dimensional geometry is coordinate axis, coordinates of the point, name of the octants. In real life, we need three numbers which are representing the perpendicular distance of the point from the three mutually perpendicular planes. The three mutually perpendicular planes are called coordinate axis, and the numbers which are representing the distance of the point from these three mutually perpendicular planes are called coordinates of the numbers. So, my dear students, any point in the space has three coordinates having the names as x, y, and z. Now consider three planes intersecting at point O such that these planes are mutually perpendicular to each other. These three mutually perpendicular planes intersecting each other intersects at the straight lines, namely x dash ox, y dash oy, and z dash oz. So these three lines are named as x-axis, y-axis, and z-axis in the three-dimensional geometry. Now we are going to understand the concept of distance formula by using the three-dimensional geometry. The distance between any 2 points taken in the three-dimensional geometry can be calculated by using the distance formula. To understand the topic, we will take random points as P having the coordinates as x1, y1, z1, and Q as having the coordinates x2, y2, and z2. Now, by using the distance formula, d is equals to square root of difference of the x coordinate, that is x2 minus x1 whole square, added to the difference of y coordinate, that is y2 minus y1 whole square, added to the difference of z coordinate, that is z2 minus z1 whole square. By performing the calculation, we can easily calculate the distance between the two randomly taken points in the three-dimensional geometry. Now we are going to. So, my dear students, you have understood how to calculate the distance between the 2 points in the three-dimensional geometry. So now, using the same concept, we are going to understand to calculate the distance of the point from the axis, that is from x-axis, from y-axis, and from z-axis. To understand the concept, we will take once again a random point P having its coordinate as x, y, z. Now suppose if we want to calculate the distance of the point P from x coordinate, then it's going to be square root of y square plus z square. Similarly, if you want to calculate the distance of this point P from y-axis, then it's represented as PB is equals to square root of z square plus x square. And exactly in the same manner, suppose if you want to calculate the distance of point P from z-axis, then it is going to be equal to PC equals to under root of x square plus y square. Now moving further, we will be using the concept of section formula. The concept of section formula is used to calculate the coordinates of the point P, which is dividing any 2 points A and B in the ratio of m/n. So to understand this topic, we will take a random point A and B as A having the coordinates x1, y1, z1 and B is having the coordinate x2, y2 and z2. To understand, let's suppose that P is a random point which is situated on the line joining the 2 points A and B, which is dividing the line segment AB in the ratio of m:n. Now suppose if we want to calculate the coordinates of point P, then the x coordinate of the point P is going to be calculated as mx2 plus nx1. In the denominator, m plus n, that is sum of the ratios. Similarly, we can calculate the y coordinate of point P as my2 plus ny1, in the denominator m plus n, that is sum of the ratios. In exactly similar manner, we are going to calculate the z coordinate of point P, that is mz2 plus nz1, in the denominator as m plus n. Now moving further, midpoint formula is one of the most important formula which is going to be used when we are dealing with the chapter three-dimensional geometry. This midpoint formula is actually an evolved version of section formula. In the section formula, the random point P is dividing the line in the ratio m:n, whereas in the midpoint formula, the random point P is dividing the line joining the point A and B in exactly the equal ratios. So the distance between the 2 points having the coordinates A x1 y1 z1 and b x2 y2 z2 can be calculated by using the midpoint formula as x1 plus x2 upon 2 for calculating x coordinate, y1 plus y2 upon 2 for calculating y coordinate, and z1 plus z2 upon 2 for calculating z coordinate. Now we have reached to yet another important topic of this chapter, that is the centroid of a triangle. The centroid of the triangle is basically a point which is obtained where the medians of the triangle intersect each other. This point is represented by the capital letter G, and this point divides the median in the ratio of 2:1. We can calculate the centroid of the triangle with the vertices A x1 y1 z1, B x2 y2 z2 and C x3 y3 z3 as G is equals to. Now when we are calculating the x coordinate, we will add the x coordinates of the vertices, that is x1 plus x2 plus x3 upon 3. Similarly, we are going to calculate the y coordinate of centroid as y1 plus y2 plus y3 upon 3. Exactly in the similar manner, we are going to calculate the coordinates of z-axis, that is z1 plus z2 plus z3 whole upon 3. I hope you all have understood the topic really well. And if you liked the video and found it helpful, then please like, share and subscribe the channel. Don't forget to press the bell icons to receive the latest info. Thank you.